Hi, welcome to Physics 2.1 Vertical Motion. Today we're talking about dropping and throwing objects down. So here are your variables to consider. Initial velocity, or V naught, is the vertical velocity the object is thrown, launched, shot, etc. Final velocity, V or even VB, is the vertical velocity at the bottom. Time is T, is the time to reach the ground. Acceleration is A, or sometimes G. This is the downward acceleration of gravity. Remember, once an object is in the air, the only thing acting on it is gravity, which is negative 9.8 meters per second per second. So here are some facts to know. 1. Up is positive, down is negative. The acceleration of all objects in the air is A, which is equal to G, which is equal to a negative 9.8 meters per second down. If an object is going up in the air, the acceleration is negative, but the velocity is positive. If an object is going down in the air, the acceleration and velocity are both negative. So this is the diagram that we'll be using. Notice that the dots do separate more. That does mean it is speeding up. So we have vertical acceleration of a negative 9.8. That is whether it is falling, being dropped, or being pushed down. So, falling objects. Since falling objects only have one direction, it did not matter where the knot was, or that acceleration went down. We did those problems in 1.4 as if everything was positive and it worked out. However, now we're looking at 2 dimensions. We definitely have to take direction into account. So notice at the top up here, the object you're dropping, V naught is equal to 0 for dropping objects. Your height is delta y. At the bottom, you have your time and your velocity that you can find. Acceleration is always negative, and your y naught is 0 at the bottom. When you go to throw objects down, direction is so important. Acceleration is negative and y naught is 0 at the bottom of the path. So notice that your v naught is less than 0. It's a negative number for throwing objects down. So on your formula sheet, you may want to add these things. These are your kinematics, but what I want you to notice is that y is your vertical height in meters. Y naught is the height of the ground, which does equal 0. A is your vertical acceleration of negative 9.8 meters per second. T is time in seconds. V naught is the initial velocity in meters per second. Could be a negative number or 0. V is your final velocity, your velocity at the bottom, and delta y is your change in height, your displacement. So you're going to use kinematic 2 to find height, only to find height. Because we now have a V naught, we cannot use this to find time unless it is a dropped object. You're going to use kinematic 1 to find time or velocity, but do remember that you have to have 3 of the 4 variables in order to find it. And we're going to use kinematic 3 to find velocity or height. You may want to write those down. So let's walk through a couple of examples. Example 1A. An object is dropped from some height and hits the ground with a velocity of 3 meters per second. How long did it fall? Well, using kinematic 1, V is equal to V naught plus AT, V is a -3 because it is coming down, heading in the negative direction. V naught is 0 because this object was dropped. Acceleration is a -9.8. Solving that equation, time then would equal 0.306 seconds. Part 2, or part B of that same example, is how high did it fall from? If it hits at that velocity and has that amount of time. So we need to find height. We're going to use kinematic 2, substituting in all of the values that we know, V naught being 0, T found in part A of 0.306. Calculating that out, we get y to be a negative 0.459 meters. Now that doesn't mean that it's in a hole. The negative indicates that it traveled that far in a negative direction. It came down. All right, throwing objects down adds an additional wrinkle. Example 2A, Nick is standing at the edge of his building 66 meters from the ground. If he throws a jelly bean down with an initial velocity of -14 meters per second, what will its velocity be when it hits the ground? Well, the only way to find this is to use kinematic 3 because time is nowhere in this problem. In kinematic 3, I have the height and I have the initial velocity. I can find the final velocity. So v squared is equal to -14 squared plus 2 times -9.8 times a -66 because it is coming down, ends up velocity being a -38.6 meters per second. Now you'll notice if you do the math, you actually get a positive answer, but remember your square root rules. You can have, when you take the square root of v squared, you're going to get plus or minus depending on the direction. Part 2 of this is how long does it take to reach the ground? We can use kinematic 1 for this, substituting in our final velocity that we just found. Be careful with all of the negatives. We get 2.5 seconds. And part C is how much faster does it reach the ground than if he just dropped it? Well, that means we have to find the drop time. Drop time from 66 meters is the square root of 2y divided by a, which should be 3.67. Subtract to find the difference, so it reached the ground 1.17 seconds faster. You're going to do several problems in class. Thanks for watching.